Hey, what's up, Algebra 2? It's Ryan. Today we're going to be talking about the unit circle, which, in my opinion, is one of the coolest lectures you'll hear in this entire course. I remember as a math student, as an Algebra 2 student, when I first heard this lecture, I was like, yo, that's pretty dope. And that's coming from someone who likes math, a little bit of a math nerd. But I think even if, this isn't your jam, you'll find this to be pretty cool. Um, I'll also say that, in my opinion, this is the one of the most, if not the most important lecture you'll hear in this entire course. Um, it serves as the foundation for trig. It's a huge part of trig, and trig is most definitely going to show up in your pre-calc, calc, maybe linear algebra. All these future math courses are definitely might reference trig, so it's important that we understand the unit circle, because this will be referenced on a daily basis in your calc classes. So take out your pencils, your paper, maybe take some notes, and yeah, let's get started with this. So first, I'm going to talk about some special right triangles, okay? So first we have a 45, 45 um, degree triangle, 45, 45, 90 triangle, where this angle is equal to 45 degrees, this angle is equal to 45 degrees, and this is a 90-degree angle, a right angle, okay? And so when you talked about this in class, right, these maybe you've seen these types of triangles before, but these bases will be equal to each other. So I'm going to say those bases are equal to x, right? If these angles opposing this side are equal, they're both 45, then those sides are going to be equal, okay? And so if we just use Pythagorean theorem to find our hypotenuse, this is going to be the square root of x squared plus x squared. And that's going to be equal to the square root of 2x squared, which is just equal to x root 2, right? The square root of x, or x squared, is just x, so we can take that out. So I'm going to write this hypotenuse as x root 2, okay? Now we're going to go over a different type of right triangle, a 30, 60, 90 triangle. So here I have my right angle here. I'm going to say this angle is 60 degrees and this angle is 30 degrees, okay? So I'm going to say this side is equal to x, okay? Sorry, I don't need to put that there. So a 30, 60, 90 degree triangle, this is defined as our hypotenuse is going to be equal to 2x. So 2 times whatever this side opposing our 30-degree angle is. And then this other leg is going to be equal to root 3x, or I'm going to say x root 3, okay? And so these are just basic ratios. These are basic triangles, fundamental triangles, right triangles special right triangles that come up a lot, and they're the foundation of our unit circle. So definitely have some of these numbers memorized, and we'll be referencing this again in just a second. So actually, real quick, I'm gonna talk about something else for a second. I'm just gonna talk about trig ratios. So I'm gonna draw this triangle. This is a right triangle. So I have a right angle here. And I'm going to say this leg is y, has length y. And this leg has length x. Then our hypotenuse has length r, okay? And so we sort of talked about this last lecture. We referenced some ideas sort of adjacent to this. But what we're going to do is we're going to look from this perspective. So I'm going to draw a little eye, okay? So we're looking from this perspective, and we're looking at our triangle from here. And this angle has angle measure theta. Okay, theta is just a variable just like x, y, or r, but it's representing this angle measure, okay? And so what we want to do is we want to remember some of our trig ratios. Remember SO, CA, TOA. And really, I'm only going to talk about sine and cosine right now. But we have sine of theta, so looking at it from this angle, is opposite over hypotenuse. So opposite is going to be y over hypotenuse, which is r. Now for cosine of theta, that's going to be equal to adjacent, right, ca, adjacent x over hypotenuse, which is r. So x over r. Okay? And we're going to tie these two ideas that we've just talked about together. And we're going to talk about some special, or we're just going to tie these two ideas together. So now let's talk about a 30, 60, 90 triangle, okay? So I'm going to draw this triangle that looks like this. Okay, something along these lines. And this is a right triangle. And I'm going to say that my hypotenuse is equal to 1, okay? I'm going to say that this angle measure, our theta, is equal to 30 degrees, okay? So let's look at this 30, 60, 90 degree triangle. If our hypotenuse here is equal to 2x, and x is our side opposite to 30 degrees, and here our hypotenuse is equal to 1, what would x have to be equal to? Well, 2x equals 1, x would have to be 1/2. So this side opposite to 30 degrees would be 1/2. Now if 1/2 is x, and this other leg, so remember these two triangles here and here are the same, except this one is actually this rotated 90 degrees, 90 degrees clockwise and then reflected. But these two triangles are the same thing. They're both 30, 60, 90 degree triangles. And so if this 1/2 is equal to our x, is the same as this side here, then we can find this other leg, which corresponds to this leg, by multiplying x by √3, right? We said that before. And so if x is equal to 1/2, we do 1/2 times √3. I'm just going to write that as √3 over 2. Okay, perfect. Now we're going to talk about another scenario. I'm going to draw this in green. So we have, in this case, we're going to have a 45, 45, 45, 90, 45, whatever you want to say, degree triangle. So this, our theta is going to be equal to 45 degrees. Our hypotenuse is going to be equal to 1 again. Now let's think about this. Before, our hypotenuse was equal to x times √2. So the length of our legs times √2. So if x, I'm just going to write this off to the side. If x if x √2 is equal to 1, x would be equal to 1 over √2, right? But I'm not going to write that. We don't want radicals on the denominator, so I'm going to multiply by √2 over √2. Rationalize this. I'm going to get √2 on the numerator over 2, because √2 times √2 is just 2. So our x is equal to √2 over 2, and that's our legs, okay? So I'm going to zoom in here, and each of these legs are equal, right? Sorry, this is a right triangle, are equal to √2 over 2. Okay, perfect. Now we're going to talk about our third triangle. I'm going to do this one in red. And this is the exact same as the first one, except it's rotated a bit. This is actually, right, sorry, let me zoom out. This triangle and this triangle are the same, okay? So here, this is a right triangle, and this is a 30, 60, 90 degree triangle. So this is going to be 60 degrees. Again, I'm going to set my hypotenuse equal to 1. Okay? And I'm going to find my x. So, right, remember from up here that our hypotenuse has length 2x, where x is our short side. So we see here that our short side in this case was 1/2. So our short side in this case is also going to be 1/2, right? 1/2 times 2 gives us 1. We also see that our long side is equal to √3/2, because when our short side, our side opposite to 30 degrees or adjacent to 60, right? In this case, this side is adjacent to 60. Our long side, our long leg, is equal to x times √3. So 1/2 times √3 gives us √3/2. Okay? And so now you're probably asking, Ryan, you've kind of gone all over the place. You've talked about some special right triangles. You've talked about some trig ratios, and now you're doing those special right triangles again. And we have this hypotenuse of 1 at all points, or for all these triangles. What are you doing? It'll all make sense in a second. I'm going to draw a coordinate plane, okay? So I'm going to draw something like this. Actually, I'm going to draw this again because this is a fun lecture, but I also want it to be good. So I don't want to mess up some of these drawings. Okay, so something like this. What I'm going to do is, you see this blue triangle. I'm going to draw this again. Actually, you know what? I'm sorry. Sorry, I'm kind of all over the place here. But I'm going to make this a little bigger. Okay? Perfect. Okay, so I'm going to draw that again. So we have a big coordinate plane. Perfect. Maybe this line. Sorry, I keep on doing this all these times. Oh my gosh. My bad, y'all. Something like that. That's good enough. So you see this blue triangle. I'm going to draw that blue triangle again, except on this coordinate plane. So I have a blue triangle, and it's going to look something like this. Okay? So this has radius 1, right? Just like I'm going to try to have that other blue triangle in screen. But I'm going to say this has, our radius is equal to 1. Okay, so I'm just putting this on a coordinate plane. So again, this is our angle measure is going to be 30 degrees. And our short leg here is going to be 1/2. Okay? And our long leg here is going to be √3/2. Okay? I'm going to take a second to stop. I'm going to take a second to stop. Remember how we said, in this case, sine is equal to y/r. So this opposite side over r. In this case, if sine of 30 degrees is y/r, that means 1/2 over 1. Anything over 1 is just itself. So sine of 30 degrees is going to be 1/2. Okay? I'm going to also calculate what cosine of 30 degrees is. So cosine of 30 degrees is going to be root 3 adjacent over r, right? X over r. So, right, r is 1, so it doesn't matter. So cosine of 30 degrees is going to be root 3 over 2. Okay? In here, we have a point right here. This is our endpoint. We move root 3 over 2 in the x direction. Then we move up in the y direction. Okay? We move up 1/2. Okay? So we have this point here, this final point that we end at is going to be, if we put this as a coordinate point, sorry, I'm going to draw that a little bit bigger. It's going to be root 3 over 2, 1/2. Okay, great. And, sorry, I don't know why this isn't zooming out. So when we say so sine of 30 is 1/2. In this case, right, I don't know if you can see it's super small, but sine of 30, or sine of theta is y over r. If r is always equal to 1, then sine is always going to be equal to y. It's our y coordinate here. Cosine of theta equals x over r. If r is always equal to 1, which in all of these cases, right, r, which our hypotenuse is always equal to 1, then cosine is going to be equal to x. So we see root 3 over 2 as our x value here. Okay, this is something important to understand, that sine corresponds to y and cosine corresponds to x. Okay? I'm going to write this up here because it's something important. Sine of theta is y, and cosine of theta is x. Perfect. Okay, now let's draw this little green triangle here. So let's see. This is also my first time doing this lecture. So forgive me if it isn't the best, or if I don't have the best drawings. That was a pretty good straight line, if I say so myself. But, so yeah, just give me a little bit of grace here. So this is another right triangle, just like this right triangle. And we're going to have a radius, or a hypotenuse here of 1. I'm not going to write that out, but it's 1. And this bottom half, this bottom leg is equal to root 2 over 2. And this other leg going in the y direction is also equal to root 2 over 2. So I could label that, I'm not going to. But essentially, this point that we end at, we go over root 2 over 2, right, in the x direction. So I'm going to say our x coordinate is root 2 over 2. And our y coordinate is also going to be root 2 over 2. Because this side of our triangle is equal to root 2 over 2, right? So this is our x, and this x is equal to root 2 over 2. This is our y, and that's also equal to root 2 over 2. Okay, perfect. And some of this, all right, this is my first time doing this, so it isn't perfect. I'm going to erase that. I'm going to say this little thing is equal to 30 degrees. This little thing is equal to 45 degrees, right? That was our green triangle. So we have one more triangle. That's going to be a red triangle. And so that's at 60 degrees. So let's draw that. So here we're going to have a little side here. And then we go vertically like this about. And we impose this triangle onto this coordinate plane. Okay? So this is 60 degrees. So let's write that. 60 degrees. And we end up at this point up here. So again, we have a hypotenuse equal to 1. Let's go down here. And our lower leg here is 1/2. This is our leg going in the x direction. So our x value, once we get to this point, right, we go 1/2 in the x direction. So I'm going to label this point as 1/2. Okay? And then our y value, once we get to this point, or our leg going in the vertical direction, is equal to √3/2. Okay? So this is equal to √3/2. I'm going to take it a second to stop us here. Let's look at what we have. So we have a 30 degree triangle where theta is equal to 30. And we have points √3/2 and 1/2. Then we have this green triangle, which is our 45 degree triangle. And that's our x and y values for that point. When we produce this triangle, we end up at this, our upper point is going to have the coordinates √2/2 and √2/2. And these coordinates correspond to the x value and the y value to get to that point, and they correspond to each of the legs going in the horizontal and vertical direction of our triangles. Then we have this red triangle where theta equals 60 degrees. And when we do that, our leg going in the horizontal direction has a length of 1/2. So our x value is 1/2. And our leg going in the vertical direction also has a length of √3/2. And so our y value is √3/2. Okay, perfect. Now, what I'm going to do is, once we have all this information, we understand this. What if I take this right triangle, or this red triangle, which is also a right triangle, and reflect that across the y axis? So this isn't perfect. And create something like this. Okay? This is the exact same triangle, except it's reflected across the y-axis. So we end up at this point. Okay? What would the coordinates of that point be? Think to yourself, what would the coordinates of that point be? Well, it's the same triangle as this red triangle, except our x value is now negative, right? We're in this second quadrant, and so our x value is negative, but our y value is positive. It's still the same coordinate. Our horizontal length has the same, or horizontal legs have the same length, but they're just going in opposite directions. So we're going to have, this point is going to have coordinates -1/2, -1/2, because we're now negative, but we're still going up √3/2 to get to this point. So our y value is still √3/2. Great. Now let's do this green. Sorry, I just want to get this about right. Something like that. I don't know if that's good, but it'll do. Okay. So this 45 degree triangle is just like it was here. Oh, my bad. I made a little mistake. Or I just forgot to say something. We had 30 degrees, 45 degrees, 60 degrees. Once we get to this vertical, or this y-axis, we've rotated. If I'm rotating like this, we've gone 90 degrees once I've gotten to the y-axis. But here, I need to go 30 degrees more, right? This angle is 30 degrees because this angle, right, for a red triangle is 60 degrees, and this is 180, right? If we go all the way down here, this is 180. 180 minus 60 is going to be 120. So I'm going to label this this red triangle as having angle measure of 120 degrees, right? Which makes sense because we get to 90 here and we go 30 more to get to 120. Okay, I'm going to erase this. Also going to erase this one. Okay, so we've gotten to 120 degrees. That's for the red triangle. For this green triangle, we've gotten to 90 degrees, and then we go 45 more. So 90 plus 45 is 135. So I'm going to label this 135 degrees. Okay? And this is going to get kind of messy, but it's fine. So now let's think about the coordinates of this point. Well, it's the same triangle as this green triangle in this first quadrant. But again, our x value is negative because now this triangle, our horizontal leg, is going in the negative direction. So I'm going to write the same coordinate points, except to have that negative sign out in front of our x value. Perfect. Now we have our blue triangle. All right, this is starting to come together, starting to look a little cool. Oops, my bad. This is hard drawing. Let me see. Definitely give Mr. Whitaker, who was my teacher that I learned this from, some credit. Because this is fun, but it's also kind of hard. Okay, so we end up at this point. Let's think about our degree. This angle right here would be 30 degrees from this x-axis in this negative direction. And so once we've gone in the negative direction, our negative part of our x-axis, that's 180. So if we go 180 minus 30, because this angle is 30, I'm going to say this is 150. Right? Yeah. 150. And right, all of these angles, 150, are saying we've rotated 150 degrees from the positive x-axis in the in the counterclockwise direction, right? That's convention. Okay, so for 150 degrees, this blue triangle, which is our 30-degree triangle, it has the exact same coordinates as our blue triangle over here, except again, we have a negative x value. So this is going to be equal to negative root 3 over 2, 1/2. Perfect. Okay, at this point, I'm going to erase some of this just for clarity's sake. Okay, this is starting to come together. It isn't perfect. I'm starting to realize, but it's all right. Okay, now what I'm going to do is I'm going to take this blue triangle and I'm going to reflect that across the x-axis. So I'm going to create this same triangle here. Go something like this. Oh, that is horrible. Yeah, don't mind that. Sorry, this is kind of hard to draw. And I'm not an artist by any means. Okay, so something like that. It isn't perfect. And we're going to end up at this point. Okay? And so now let's think about our angle. So this is 180, and we've gone 30 degrees more, right? This angle right here is 30. So 180 plus 30 would just be 210. 210 degrees. Perfect. Now, let's think. Right here, we had negative root 3 over 2 and 1/2 as our coordinates for this point. What do you think the coordinates for this point, it's a blue triangle again, would be? it's going to have the same magnitude, but since we're in the third quadrant, we have both of our coordinates are going to be negative, right? We're going in the negative direction for this horizontal leg and the negative direction for this vertical leg. So I'm going to have negative root 3 over 2 and negative 1/2. Perfect. Okay. Then let's draw our green triangle. This might have gotten a little bit messed up, but it's all right. So this green triangle, we're going to go about here-ish, I guess. Sorry. Okay. Something like that. Yeah, this definitely got messed up. And we're gonna end up at this point, right? This point here. So again, what do you think our coordinates are gonna be at this point? It's gonna be the same thing as this except negatives. So I'm gonna have negative root 2 over 2 and then negative root 2 over 2. Perfect. Okay. Then, oops, yeah, sorry, oops, I'm not sure. Let's think about the angle measure for this green triangle. This is 180, right? But we've gone 45 degrees more. So 180 plus 45 is going to be 225. 225 degrees. Perfect. Then we have this red triangle. Let's see. So we draw something that goes a little bit like this, I guess. I think that looks good. And we end up here. Okay, perfect. So let's think about the angle measure first, so I don't forget it. Well, this is 180, but we've gone 60 degrees, right? This angle is 60 degrees, this angle is 60 degrees. So what's 180 plus 60? That's going to be 240. Okay, now let's think about the coordinates of this point. Same thing as this for all the red triangles, except both of our coordinates are negative. We're in the third quadrant. So we have negative 1/2 and negative root 3 over 2. Perfect. Okay, now we're going to do, so you start to see a certain shape come together, ideally. If I was a good drawer, a good artist, you'd see a certain shape come together. So now I'm going to draw this red triangle again. Something like this. And we end at this point. Okay, so let's think about the angle measure. Well, this is 180. So what angle would this be? This negative part of our x-axis. Well, it's 90 degrees more. So 180 plus 90 would be 270. So this is 270 degrees. Okay, and then we rotate 30 more degrees, right? This angle is 60, so we need to rotate 30 more to get to this angle. So 270 plus 30 is 300. If we also just think about this, one full revolution is 360. So 360 minus 60 going back here would get us to 300 too. Now let's think about those coordinates. I'm going to look up here. Well, we know it's going to be, since it's a red triangle, it's going to be 1/2 root 3 over 2 in some form. But our y value is going to be negative in this case, and our x value is going to be positive because we're in the fourth quadrant. So we're going to have positive 1/2 and negative root 3 over 2. Great. Then let's do this green triangle. Now, yeah, let's see here. So we draw this out. And we end at this point here. And so let's calculate our angle at this point. Well, it's 45 degrees from 360. So 360 minus 45 would be 315. And some of these angles, I don't really know how to annotate them, where to put it, but 315. I'll show you some things after. So 315 degrees, this is a green triangle, so a 45 degree triangle. And so our coordinates here are, our x value is going to be positive, our y value is going to be negative. So we're going to have positive root 2 over 2 as our x value, our y value is going to be negative root 2 over 2. So we have root 2 over 2 as our x value, and negative root 2 over 2 as our y value. Perfect. And then we're almost completed. We have this blue triangle once more. And here, this does not look good at all, but it's all right. It's so uneven. But we end up here. And let's think about our angle measure, right? This angle is 30. It's 30 degrees from 360. So 360 minus 30 is 330 degrees. Okay. And then what is this point going to be? Well, it's just this point, except our second value, our y value, is negated or negative. So we have positive root 3 over 2 as our x value, and negative 1/2 as our y value. So we have this shape. We have all of these triangles coming together. And so what I'm going to do, and this isn't going to be perfect because I did not sketch this great, but I'm going to try to draw a little circle. Oh my gosh. Or I'm going to start from here, even though maybe that would not make intuitive sense, but it's just easier for me to draw this. And then we go here, something. This isn't the best drawing, okay? I'm sorry about my drawing skills, and this lecture is definitely dependent on drawing skills heavily. Yeah, this is starting to look pretty ugly. Oh my gosh, I'm so sorry. Theoretically, this would be a circle. It most definitely is not. It is far from perfect. But theoretically, this would be a perfect circle where our radius is equal to 1, right? In all of these triangles, down here, our hypotenuse was equal to 1. In all of these triangles, our hypotenuse is our radius, right? Our center is here. This would be the edge of our triangle, or our circle. And our hypotenuse is extending from our origin, our center, to the edge. So our hypotenuse is the radius, hence why I had it as r over here in this initial example. And it's equal to 1 because, so this is the unit circle, and it's equal to 1, or it's called the unit circle because our radius is 1, right? It's 1 unit. So why is this important? This is something that's, I would not say it's revolutionary, but it's paramount within this course and paramount within trig, because we can calculate specific trig values from this, right? And so remember how before we talked about, sine of 30 equals 1/2, because the y value at 30 degrees is 1/2, and sine, right, we said sine is y, cosine is x. So if I were to ask you what cosine of 120 degrees is, which is this red triangle up here, cosine is the x. So you'd get the x coordinate of this unit circle, which is -1/2. So cosine of 120 degrees is -1/2. If I were to ask you what sine of 225 degrees, you'd come to this green triangle down here, and since sine is y, you'd get the y value, so -√2/2. If I were to ask you what's cosine of 330, cosine is x, and so you go to this triangle that correlates to 330 degrees, you get the x value, so √3/2. And this serves as the framework, some very common trig values that you need to know. So this may seem like a lot, but you need to remember this entire unit circle. And we're going to add on something real quick. We're going to add on radians, and I'm going to go back to memorizing this because this looks a little complicated, right? It isn't that bad to remember. You just need to remember this upper quadrant, and all of the rest of the three will follow. So real quick, let's do radians. All of these are in degrees, so we want to write them in radians. We want to be able to go through each of them. And so last lecture, we talked about going from degrees to radians. So from going to degrees to radians, we need to multiply by pi over 180. So 30 times pi over 180, 30 divided by 180 is 1/6. So this is 1/6 times pi, so 30 degrees correlates to pi over 6 radians. 45 times pi over 180, 45 over 180 is equal to 1/4. 1/4 times pi is pi over 4. Okay? Then 60 degrees is, or when we multiply by pi over 180, 60 divided by 180 is 1/3. Multiplied by pi gives us pi over 3. Okay? Perfect. Now I'm going to add something, actually. Oh, sorry, I keep on adding things. I'm going to add points on these x and y axis. So at this point, this is equal to 1, 0, right? Our x value is equal to 1 because that's our radius, and our y value is equal to 0, right? We're in the x-axis. So this is 0 degrees, 0 radians. Here, for this point, this is 0, 1. And this is 90 degrees. And 90 degrees times pi over 180 is pi over 2. Okay? Then let's go here. Let's keep on converting this to radians. Sorry, I'm kind of all over the place. So now we have 120 times pi over 180. 120 divided by 180 is going to be 2/3 times pi. So we're going to have 2 pi. 2 pi over 3. Now we have 135 degrees. 135 divided by, or times pi over 180 is going to give us 3/4 times pi. So this is going to be 3 pi over 4. I'm going to kind of go fast, and you can confirm these for yourself. 150 times pi over 180, that's going to simplify to 5/6. 5/6 times pi is going to be, it's going to be 5 pi over 6. Okay? And we have this point here. And this coordinate is going to be -1, 0. Okay? And so this is equal to 180, right? This degree measure. And 180 times pi over 180 is just pi, right? We talked about this before. 180 degrees is equal to pi radians. Okay, now we have 210. 210 times pi over 180, we're just speed running this at this point, is 7 over 6. So I'm going to say 7 pi over 6. 225 times pi over 180 is going to be 5/4. So this is 5 pi over 4. And 240 times pi over 180 is going to be, my bad, I'm tripping, 4 over 3. So 4 pi over 3. Okay, sorry if I'm going kind of fast. You can slow it down and calculate these for yourself. I'm going to put another point down here. What's the coordinate of this point going to be? Well, this radius is equal to 1. So let me see. Yeah, I just want to make sure I did everything right. This coordinate is going to be equal to 0 and -1, right? And this is 270 degrees. And that in radians, 270 times pi over 180 is going to be 3 pi over 2. Now 300 times pi over 180 is going to be 5/3. So 5 pi over 3. 315, yep, 315 times pi over 180 is going to be, sorry, I'm tripping, 7/4. So 7 pi over 4. And then 330 times pi over 180 is going to be, my bad, 11 over 6. So 11 pi over 6. And then we get to a point where this is 0 degrees or 360 degrees. Sorry, oh Lord. This is also messy, but I've kind of given up. So this would either be 0 radians or 2 pi radians. Okay. Sorry, I just can't. This isn't my best work. But this is the unit circle, okay? So I was talking before about you're going to have to memorize this. And it is so important that you memorize this. And it's not, you'll probably have a quiz on this in class. And what I really don't want you to do is use your short-term memory and memorize some of these values just for that quiz. I want you to sear this into your brain so that you cannot forget it. And I know that sounds extreme, but I need you to do that. I've said to the class I TA'd last year, and now they're in pre-calc, and they're still using this. They're still like people in calc are still using this. It's so important that you understand all of these values. So I'm going to talk to you about some ways I remember these values. So we really, because, right, like I was talking about before, you're going to be asked to say what sine of pi over 2. And you have to know that sine is y. So with the coordinate here, you have to grab the y coordinate at this point, and that's going to be 1. Or sine or cosine of 5 pi over 4. Cosine is x. At this triangle, the x value is -√2 over 2. Well, first, let's understand that all of this is repeating, right? We have this blue triangle that repeats 4 times, right? This, let me see, I'm going to box this in blue. This value, these coordinates essentially repeat themselves 4 times, except the signs out in front of one another. Oh, my bad, not that one. Not that one. They essentially repeat one another, okay? Except the signs out in front, right? In this second quadrant, we have a negative sign in front of our x coordinate. Here in the third quadrant, we have a negative sign out in front of our x and y coordinates. And here we have a negative sign out in front of our y coordinate. But they repeat themselves, right? So when I say you only need to remember this first quadrant, you can take all that knowledge you remember from that first quadrant and translate that to the other three. So that being said, how do you remember these values in the first quadrant? Well, there's a couple of different ways. There's a couple of different strategies. Everybody remembers things differently. As I'm looking at this, I'm getting kind of mad that this fraction is kind of on a slant, whereas all of them are vertical. So I'm going to write this as 1/2. Sorry, this is my OCD. All of these are over 1/2. So you can start there. And then you see that our x values go from 3 to 2 to 1. And here our y values go from 1 to 2 to 3. Then you can remember that you square root both of these 2's and that you square root the 3's. You don't have to square root the 1's. The square root of 1 is just 1. That's one way you can memorize it. And just do it like that. And then reflect all those values over here. Except now, make sure to put your negative signs accordingly and do that for all the other quadrants. How I remember it is I remember two triangles. I essentially remember these two triangles and that's it. So I know that in my 30, 60, 90 triangle, right? Remember that this red triangle and this blue triangle are the same except they're rotated a bit. They still have the same values of 1/2 and root 3 over 2. So I know in my 30, 60, 90 degree triangles that the short side is going to have a value of 1/2 and the long side is going to be equal to root 3 over 2. Additionally, in my 45, 45 degree triangles, I know that both of my sides are equal to root 2 over 2. So I automatically know that. So essentially, what I want you to do is burn this into your head. And once you burn this into your head, like I can look, I sort of look into the air right now and I think of the unit circle. So imagine I'm thinking of this in my head. When I get the value 30 degrees or pi over 6, I see this triangle. And I don't really remember these coordinates, but I remember my horizontal leg going in the x direction is long, and this vertical leg is short. So I remember long legs is root 3 over 2, and our short leg is 1/2. And so that way when I get to 60 degrees, or pi over 3, I remember that same triangle, except I remember short side is x, long side is y. So our short side, our x value, since it's short, it's going to be 1/2. And our long side is going to be root 3 over 2. And I know root 3 over 2 is greater than 1/2, right? Because root 3 is greater than 1. Because root 1 is just 1, right? So yeah. So that's how I remember that. And then I remember these green triangles, right? 45 degree triangles. So 45, 135, 225, 315. All that is just root 2 over 2 and root 2 over 2. It's the same. And so I don't really remember the coordinates. I remember, is it long side, short side, or sort of in the middle? And it's the same for both legs. And then if it's a long side, it's root 3 over 2. If it's a short side here, it's 1/2. Then I remember it like that, and then I assign the correct negative or positive for each of those. And then, I'm sorry, this is just keeps on going because there's a lot of memorization to this. You can, I've seen a bunch of different strategies for memorizing the radians and the degrees and stuff like that. So you see we have 6, so all of these have pi, obviously. But here in this first quadrant, we have denominators of 6, 4, and 3. And we have 6, 4, 3, 6, 4, 3, 6, 4, 3. So you can sort of remember that these sort of inside angles are going to all have denominators of 6. These ones are going to have denominators of 3. And then you can sort of notice patterns here, right? We have pi over 3, 2 pi over 3. This would be 3 pi over 3, but right, that just simplifies to pi. Then we have 4 pi over 3, and then we have 5 pi over 3. And this would be 6 pi over 3, but that's just 2 pi. Here we have pi over 4. This would be 2 pi over 4, which is just pi over 2. 3 pi over 4. 4 pi over 4, which is just pi. And then, 5 pi over 4, 6 pi over 4, which simplifies to 3 pi over 2, 7 pi over 4. I'm just talking a lot. There's a bunch of different ways you can memorize these radians. I sort of just, I kind of reason my way through, I guess. You can think about it as this quadrant, our second quadrant, all of our numerators are 1 less than our denominators. Here, you can think about our numerators are 1 more than our denominators. Here, our numerators are 1 less than twice our denominators. That might be helpful. I have not really thought about it that way. But there's a bunch of different strategies to remember all this. Just know that there's a lot of repetition here. So you only need to memorize one quadrant. But definitely explore a bunch of different strategies to understand this and really get this into your brain so that you cannot forget this, because this is one of the most important things we'll go over all year, and it's something that's going to be continually referenced in future math classes. So hopefully you've enjoyed this lecture. I kind of botched it. It wasn't the best. Circle wasn't my best work. Something to improve on. But if you do have any questions, please reach out to me. This is, as I've said numerous times in this video, this is a very important lecture. So please reach out if you have any questions. It's imperative that you understand and memorize all of this material, and I'm happy to help you in doing that. Also, just go to your teachers. Maybe talk to some upperclassmen. How did they memorize it? Do they use this in their math class? And they will tell you they do. Use the internet and use all the resources available to you so that you get this under your belt and you understand this, because it's going to be continually referenced moving forward. Okay, thank you, and I hope you have a great day. See ya. Bye.